Sequencing activities is an important part of project management since it ensures that tasks are completed in the proper sequence to meet project objectives effectively. Project managers use a variety of tools and approaches to help with the sequencing process. The essential tools and approaches that are discussed in this lecture are Precedence Diagramming Method, Dependency Determination and Integration, Leads and Lags, and Project Management Information System. Project managers may make a well-structured project schedule, optimize resource allocation, and increase project success by utilizing these tools, practices, and techniques. Let's look closely at each of the tools and techniques of this process. First, we have the Precedence Diagramming Method, or PDM. The Precedence Diagramming Method is a popular tool for project management activity sequencing. It displays activities and their relationships graphically, helping project managers to determine the logical order of work. A predecessor activity is an activity that logically comes before a dependent activity in a schedule, whereas a successor activity is a dependent activity that logically follows after another activity in a schedule. Let's discuss the types of dependencies. PDM recognizes four types of dependencies: finish to start relationship, a logical link in which a successor activity cannot begin until the predecessor action has been completed. For example, installing an operating system on a PC cannot begin until the PC hardware is built. Then we have the start to start relationship, which is a logical connection in which a successor activity cannot begin until the preceding action has begun. For example, level concrete cannot begin until the foundation has been poured. Then we have the finish to finish relationship, which is a logical link in which a successor activity cannot be completed until the predecessor action has been completed. For example, composing a document that must be completed before revising the document may be completed. Start to finish relationship, which is a logical link in which a successor activity cannot be completed before the predecessor action has begun. For example, a new accounts payable system must be launched before the previous accounts payable system may be decommissioned. Next, we have the dependency determination and integration. Dependencies can be classified as required or optional, internal or external. Dependencies are of four types, but two of them can be applied simultaneously in the following ways: mandatory external dependencies, mandatory internal dependencies, discretionary external dependencies, or discretionary internal dependencies. Let's briefly discuss them. Mandatory dependencies, dependencies that are compelled by law or contract, or that are inherent in the nature of the activity, are considered mandatory. Physical restrictions are often imposed by mandatory dependencies, for as on a construction project where it is impossible to raise the superstructure until the foundation has been built, or on an electronics project where prototype must be constructed before it can be tested. Hard logic or hard dependencies are other terms for mandatory dependencies. Technical dependencies aren't always necessary. The project team determines which dependencies are necessary during the activity sequencing phase. Mandatory dependencies are not the same as scheduling constraints defined in the scheduling tool. Discretionary dependencies. Favored logic, preference logic, and soft logic are other terms for discretionary dependencies. Discretionary dependencies are built based on knowledge of best practices in each application sector, or another distinguishing feature of the project where a certain sequence is chosen, even though other acceptable sequences exist. For example, universally acknowledged best practices state that electrical work should begin after the plumbing work has been completed during construction. This order is not required, and both operations can run in parallel, although executing the tasks sequentially lowers the total project risk. Discretionary dependencies should be thoroughly described since they can result in arbitrary total float values and constrain subsequent scheduling options. External dependencies. External dependencies require a connection between project and non projected activity. These dependencies are typically outside the project team's control. For example, the testing activity in a software project may be contingent on the supply of hardware from a third party, or regulatory environmental hearings may be required before site preparation on a building project can begin. During the activity sequencing process, the project management team identifies which dependencies are external. Discretionary dependencies are also known as favored logic, preference logic, and soft logic. Dependencies on discretion are developed. When using fast tracking techniques, these optional dependencies should be inspected and considered for modification or removal. During the sequencing phase, the project team chooses which dependencies are discretionary. So let's talk about integrating dependencies. Internal dependencies feature a priority connection between project operations and are often under the authority of the project team. For example, there is an internal necessary reliance if the team cannot test a machine until it is assembled. During the activity sequencing process, the project management team identifies which dependencies are internal, leads and lags. This is our third topic. Leads and lags are useful tools in project management for adjusting activity sequencing and managing variances in dependencies. These technologies provide flexibility in project scheduling and play an important role in optimizing resource allocation, accounting for wait times, successfully managing external dependencies, and aligning activities with project limits. As a scheduling method, leads allow one activity to begin before its predecessor is finished. They introduce a time overlap between the two operations, allowing the project timetable to be accelerated. Leads are frequently employed when the project timeframe must be accelerated or when specific operations may be completed concurrently. Project managers can shorten total project length and enhance project efficiency by carefully incorporating leads. In contrast, lags are delays or waiting times that occur between tasks. They ensure that a precise time interval exists between the conclusion of one activity and the commencement of its successor. Lags are frequently used to account for practical limits such as concrete curing time or paint drying time. Project managers may guarantee that tasks are appropriately ordered by including delays, which consider essential waiting times or reliance on external sources. At number four, we have the Project Management Information System. Project Management Information System includes scheduling software that can assist plan, organize, and alter the sequence of events. It inserts logical linkages, leads and lags values, and distinguishes between different types of dependencies. See you in the next lecture.